Greetings. This is Group 2 from SEIT presenting their mini project. In our mini project, we have decided to make an Android app which will allow the user to view multiple 360-degree videos of various prominent places across the globe, be it monuments of national importance or biodiversity hotspots, so on and so forth. When a user first opens the application, the user is shown the registration page as shown here. So let us quickly type in the details. Let's say abc@gmail.com, and let us put in a password and let us confirm that password. And when we click on sign up, all these details will be stored in a Firebase database that we have connected to this app. Now this email has already been registered by us, so no need to click on sign up again. Let us directly go to sign in. So let us quickly sign in abc@gmail.com. We put in the password, and when we click on submit, it takes us to the home page. The home page has 4 buttons, as we can see. At the top we have recommend, on the left we have edit profile, at the bottom we have watch, and the rightmost we have sign out. Let us first look at edit profile. Here we already see some pre-written data here. Rahul Mehta 27 and B. So those are mainly the name of the user, the age, and the preference, the choice. So let us quickly change the data here. Let us say we have Aryan, let's say Verma, age 35, and we have 4 options here. So where would you rather go? We have 4 options. The first option that we see is the image of a hill. Then when we swipe, we see image of a beach. Then third option is that of a monument. Here it is Taj Mahal. And lastly, that of a theme park. So we can write in the letter corresponding to the image. So let us say we type in D here. And when we click on save changes, all these changes will be saved to the Firebase database that we have connected to this app. If we again go to edit profile, we'll see that those changes have been saved. Just go back to the home page. Now let us look at the recommend button. Here in the recommend page, we have 3 buttons: recommend, search, and back. Our database, our number of monuments that we have is close to is more than 1,000 entries. But there could be a possibility that the user is searching for a monument which is not present in that list. In such a situation, we have allowed the user to be able to search all the monuments that are starting from that particular letter. So let us say we type in the letter T and click on search. The app will display all the monuments in the list that start with the letter T, like Timgad, Timbuktu, Tikal National Park, so on and so forth. Then we go back. Let us say we want to know places that are similar or have some similarity, and we'll use the recommend button here. So let us see Timgad, since we had seen that in the list, and when we click on recommend, it will give us various places and the country from which it is from. So we have Tipasa, which is Algeria. Then we have Historic Center of Puebla, which is in Mexico. So it is also recommending places not just from Algeria, but also from various other countries. Then let us check another place. Let us say the Grand Canal, which is in China. And when we click on recommend, since we are only displaying the top 20 closest to the place that we enter, in this situation all of these are from China, because in China we have more than 20 entries which are close to the Grand Canal. And we can see in the second entry that it is the Great Wall has been recommended. So let us go back to the home page where we have the watch button, where we have the gallery of a few 360-degree videos that we have already uploaded. So here we see the Great Wall of China, and if we click on watch, we'll be able to see the 360-degree video where we can move around, see around, and we can also hear sound. Right? Okay, so let us go back, and we have also added a few more videos of the Gateway of India, Golden Temple, Hawa Mahal, Pichola Lake. So let us say we want to watch the Pichola Lake, and it is in Udaipur, and we can hear the background noise of crows flying, of someone ringing the bell, birds flying. So we have successfully been able to play the 360-degree video. Finally, we go back to our home page, and when the user wants has been satisfied and doesn't want to use the app anymore, the user can click on sign out, and it will take the user back to the sign in page. This was the complete demonstration of our application. Now, my colleagues Larren and Limark will explain the implementation of this project.
Yeah, for now, the implementation part of the project, uh, for ML algorithm, we've used an API which is deployed on Cloud Heroku platform, which is a Heroku platform, which is a cloud platform. So we have basically coded an Python API, Python ML code, which is present here on the GitHub link, which is GitHub link is given in the project report, and here are the codes. So basically, what it does is uh, in the API, we need to call this one function results, and it will call another functions, and also it will take the data from our data set, which is World Heritage Sites CSV. This data set contains around 1200 World Heritage Sites. So now we have taken limited data set, and it will output the ML recommendation by doing the computation. So let me show you the data set. As you can see, we have quite a large considerable dataset for initial application for test project. So there are like 1122. So as this is the raw data, we have to pre-process it, and we have pre-processed it, and we have considered a cosine content-based recommendation algorithm. Basically, what it does is it will recommend you videos based on your previous experience. So if you similar videos. So if you see a video A, it will recommend you next B CD videos which are similar to A. Yeah. So how it works is it will we have to consider some characteristics of video. We have to input in an ML algorithm, and it will consider the similarity, and it will give the output. So for here on this data set, we have considered category, states, name, and short description. These three columns, as we felt they are important, because other columns are not really here. We can compare the similarity on, as this is raw data. So we have considered these three columns, and in the code we combine them, and based on their similarities, we show the output to the user. Let me show you how the output works. So as we can see here, our app here is we have our API which is hosted here. So let's see how it works. Okay, let's open the app now. Okay, yeah. It is showing 404 as this is an API. It has no index file. So we have to put a get request here. As you can see, if you put a get request of a name that is in a database. So suppose we input Great Barrier Reef. This is a get request. We have to put the get request. So API will send us data. And as you can see, when you put Great Barrier Reef, it shows the 20 recommendations which are similar to the Great Barrier Reef. So as you can see, Great Barrier Reef is in Australia, so it first shows Australia things from Australia, the World Heritage Sites, which is quite obvious because since the data set is limited, we will see many things from Australia, but it also shows World Heritage Sites from different countries. So first, we can say that our ML algorithm is working. It is giving us different recommendations. We can also go forward, but we have only chosen 20 top 20 recommendations. Also, we have implemented another function. Since our data set is limited, we have to, a user should know many things are present. Right? We can't give it like real world apps like YouTube, where almost everything is present. But here, since our data set is limited, we have implemented, users should be able to see um, what things are available. So we have implemented another API which shows that if you put suppose an input A, it will give the result all the places that are present in the database starting from A. So let us look here. It's getting loaded. Okay, again, since the API, it does not have an index file, so no front end. So if we put here video name title equal to, suppose we give an input T, it will give us all the names which are starting from T present in a database. As you can see here, this one. So now I'd like to hand it over to Larren to explain the further stuff.
Okay, so next, now that we have hosted our ML algo, our output from our ML on the web, next up we have how to fetch this data into our app. So this is done using retrofit. What exactly is retrofit? Retrofit is a module which is built by a company called Squarespace. It's an open source software and it's a REST client. And with the use of this, it sends get commands, various commands like get, post, put, etc. And it helps in retrieving data from the JSON file that is posted on as Limark shown on the web. So there are it's pretty simple. There are three main steps. First, we send the get command with a query saying the title should be equal to whatever our input should be. Second, we have to convert this into strings or integers. So that's the second part. And finally, third is to import these two and finally and display it into a front end of the app. So that's a brief overview of retrofit. Next. Now the main thing is to play the 360 video. This we have done using the ExoPlayer module, which helps to convert first it detects whether the video is 360. There are certain options in the video, so it detects that. And next it helps to retrieve data from it and play it, and it is a separate video player. So we've integrated that in our app and we've used it to play. So next we now move on to Firebase. So the first thing is the authentication. So as we can see, all the user's data when he creates an account, it's stored here. So as you can see, various email accounts. So that's all stored here. Next, we go into the Firestore database. This is where users' details are placed. So in authentication, it was just his email and his password. Here is where his name. So we have kept three factors: name, age, and preference. So these are the three things which are stored of every user. So next, storage. This is since our app is not on a large scale, it's not possible for us to have many 360 videos since each one of them are like at the minimum 50 MB. So we have kept like around 10 to 15 videos in our storage. All of them are 360 videos, and these are the URLs of them. And when the app calls this URL, it gets played in the app. So that was a brief gist of Firebase. So now that we've understood about various modules which we have implemented in our app, I would now like to hand it over to Mohsin.
Thank you very much, Larren and Limark, for the in-depth explanation on the implementation of our project. This is Group 2 from SCIT presenting their mini project VR Tourism with the team members Mohsin Chougale, Larren Dsouza and Limark Dcunha. Thank you very much for going through our tutorial.